Good evening, all. Thank you very much for attending this makeup class. I know it is a bad time of the year because you are writing examinations, but I do appreciate the fact that despite that, you still have taken time off to come to this class. It just goes to show that you have such a great interest in problem solving and you want to improve your mathematics sufficiently. I really appreciate that. All right, so without any further discussion, we will go straight to the lesson today. This was supposed to be given on the 11th of August, and there was some hitch. I can't remember exactly what it was. But now we are going to go back to session 4, which we did not do at that time. All right. We have some very interesting problems here. They deal with different types of questions. So let's go straight into the very first question. Kotso, do we have, am I sharing? No, I'm not sharing. Okay, can you see the screen now?
Yes, Prof, we can see the screen.
All right, okay. Okay, the very first question is to solve for x in a problem which has got square roots in it. Now, the usual method to do this is to try to square in some way so that you have the square root on one side and a number on the other side. But here you got two square roots. So the best thing to do is to square on both sides. So when you square on both sides, remember the square of a square root is itself. The square of square root of 25 is 25. It's 5 squared. Okay, so the first part becomes x plus a. But remember, when you're squaring, you've got two things here which are subtracted. And when you subtract x minus y all squared, x squared minus 2xy. So you have minus 2 times the product of these two plus the square of the other term, which is x minus a. There's a plus sign in front, so I don't have to put brackets. So that's the square of the left-hand side. You must square the right-hand side as well. What you do on the left, you must do on the right. Okay, now you can see that the a minus a will cancel off, and you got 2x on this side. So I can take the 2x on this side, x plus x. I'll bring it to this side. The reason being, I want to keep the square root sign intact on one side. So here, on this side, I've got 2 minus 2 into square root of x plus a into x minus a. The square root of a product is a product of the square roots. That's an important fact. So you got square root of something times square root of something is the same as square root of the product of the two. And x plus a times x minus a, that's a well-known thing. It's the difference of two squares, so I'll do it straight away. X squared minus a squared. That's minus 2 on the side. I'll leave this as it is. And okay, the 2's cancel off. So let's divide by minus 2 on both sides. divided by -2. So this becomes x minus 1. This is 2 into x minus 1. 2 into 1 minus x. All right, so that is the same as -2 into x minus 1. All right, so now that's very much easier to handle because you got only a single square root on the side. We can square on both sides, x squared minus a squared. Again, I'm finding the square on both sides again. And here, this square is x squared minus 2x plus 1, right? This is square of a binomial. And happily, this x squareds cancel off. And the minus 2x, I can bring it on this side. And then the a squared, I can bring it on this side. I have a squared plus 1. And x is a squared plus 1 over 2. Okay? So that's the answer to this question. But there's one important thing that we have to do here. And that is because we squared, very often when you square, you bring in some terms, some solutions, which are not solutions. Let me just explain. If I start off, for instance, with, suppose I start with x equals 2. Okay, so we know what x is. X is 2. It's nothing else. X is 2. Now, if I square this thing, I get x squared is equal to 4. Right? So now this thing here has got 2 roots because this is x equals 2 or minus 2. You see? So you got an additional root because I squared it. So that is a problem. Sometimes when you're squaring, you bring in roots which are not solutions. Roots and solutions are the same thing, which are not solutions. So it would be proper to actually check to see whether this quantity here is indeed a solution. See, you have to substitute this x is a squared plus 1 over 2 into the original equation, and you have square root x is a squared plus 1 over 2 plus a, and you get minus square root of x is a squared plus 1 over 2 minus a. And we have to check to see whether this is equal to square root of 2. Although there's an a in it, it seems to be that this a is disappear. And let's try to calculate this. I'm going to do this quickly. I got a 2 here, and at the top I got a squared plus 1 plus 2a, which is a plus 1 all squared, minus, and here when you simplify this, here you get a minus 1 all squared over 2. So you have the square root of a quotient is the same as the quotient of the square roots over square root of 2. Here you have minus a minus 1 all squared over square root of 2. Notice I didn't make square root of a plus 1 all squared as a plus 1, right? Because you can only make it a plus 1. You can only take the positive square root if you know. See, a square root of 5 squared or negative 5 squared is not negative 5. This is square root of 25, which is 5. So the square root of a quantity of a square need not be the number inside. It is the absolute value of the number inside. In other words, it's negative. This one here is equal to the negative of the inside because it's negative. But if it was positive, you leave it like that. Now, you see, they said a is greater or equal to 1. So far, we haven't used that. Now, if a is greater or equal to 1, then what is being squared here is a positive quantity. So I have a plus 1 at the top. That's okay. The square root of 5 squared is 5. But here now, a is greater than 1. So a minus 1 all squared. Now the quantity is positive, you see, inside. So you leave it as it is. You don't have to change the sign. So it's minus a minus 1 over 2. And now when you simplify this, I'm not going to do it, you get square root of 2. See? So that's fine. So this is a solution. So we need to check to see whether a number is a root or a solution or not, especially when you are squaring, because sometimes you may get a number which is not a solution. All right, so that took a long time to do, but there were some very important things about square roots which we dealt with in that problem. Okay, so let's just get on to the next problem. All right, so here you've got 3 carpets have got a combined area of 200 square meters. So you've got 3 carpets. I'm going to make these carpets look round. So you've got 3 carpets. And the combined area, when you add those 3 carpets, the areas, you get 200 square meters. All right. Now they say by overlapping these 3 carpets, so the 3 carpets, they overlap. You put one on top of the other. Now, I've forgotten how you... I think you can actually select this thing. All right. I know you can select this and you can move it around, but I don't know. I've forgotten how to do that. So let's put those 3 carpets on top of each other. So you have one carpet like that. Oh, God. Another carpet like this. All right. Sorry about this. I'm going to just draw it by hand. It's not going to look very nice. But, okay, so you have 3 carpets. I want to make them overlap. Right. Now, by overlapping the 3 carpets to cover a total floor area of 140 square meters. So these 3 carpets together, they cover 140 square meters. All right, but they're all overlapping. The area which is covered by exactly 2 layers of carpet is 24. Now, this part here, there's only 1 layer of carpet here. But here, these 2 overlap. So this part here is there are two carpets here. Here too, 2 carpets, 2 carpets. And here, there are 3 carpets because all the carpets are sitting on top of each other. And so there are lots of spaces here. I'm going to give names to all these quantities. I'm going to say this covers an area of A, B, C maybe. And this is P, Q, R. A, B, C are the areas covered by 1 carpet. P, Q, R is the area covered by 2 carpets. And the question is, what area of floor is covered by exactly 3 carpets? So this part here is unknown. We're going to call it X. This is the part which is covered by 3 carpets. All right. Now, they give you lots of information. we know that the three carpets have a combined area of 200. So if I separate these carpets, I'm going to give a new name to the area covered by one carpet. Because we deal with these areas covered by one carpet in two different ways. Let's call that capital A. And the area covered by two carpets. Now this is A plus B plus C. And the area covered by two carpets, let's call it capital B. And that is P plus Q plus R. But they tell you that the area covered by two carpets, exactly two layers, is 24. So we know that B is 24. Right? But I'm just going to keep these symbols intact anyway. So we know the value of B is 24. And then, yeah, so, and the area covered by three carpets, of course, is X. That's X. All right. So let's see. They got a combined area of 200 square meters. So what does that mean? It means that you take A plus B plus C. If I open these carpets out, I'll have, this is the area covered by one carpet, but here they're doubling up, right? P is twice, Q is twice, R is twice. So you get plus 2 into P plus Q plus R. I'm going to separate. Imagine that these carpets are separated, and then this is done 3 times, and that is 200, you see? Because as I saw earlier on, when you pull them out, you'll get that. If you separate all these, you'll get these equations. So you've got, yeah, that this is capital A plus 2B plus 3X is 200. So by renaming these, like what we have done here, I've reduced it to only 2 unknowns, see? So that's very nice. So actually B is 24, right? So I can say this is A plus 3X. You bring, the B is 24, 24 times 2 is 48. 200 minus 48 is 152. So I can put the B equals 24 and bring it to the other side. So I got one equation with A and X, and my problem is to find X. What else do they say here? They say that the total floor area is 140 square meters, like as it stands here. So this means that A plus B plus C, that plus that plus that, plus P plus Q plus R. And this one here, we're not counting these twice. We're just counting the total area covered by these carpets. So you get A plus B plus C, P plus Q plus R plus X. Now that is the area in the overlap, and that's 140. So this is, we can rename this as A, and P plus Q plus R is 24. Let's put this down here. A plus 24 plus X is 140. So this means that I can bring the 24 to the other side and have my second equation. A plus X equals 140 minus 24, which is 116. And so now I've got two equations in two unknowns, and that allows me to calculate X. And it's very quickly, you can get it from here because you can simply subtract to get rid of the A's, 3X minus X. A minus A is 0, and 152 minus 116 is 36. So X is 18. 2X is 36. X equals 18. All right. Okay, so this, although it looks as if you got 7 unknowns here, we solve the problem by naming one thing which keeps repeating, giving it another name, a new name, and then it's easy to solve. All right, so that takes care of that problem. Let's get on to problem number 3. A, B, and C are positive integers such that the product, they're integers now, that's very important. So they're not any numbers, they are integers. And they're positive. That's very nice. I like positive numbers. 1, 2, 3, 4, 5, and so on. So you don't have to deal with the negative ones. So they are positive integers. And the product, A times B times C, is equal to their sum. So now there could be many solutions to this. We don't know how many solutions there are. Which 3 numbers, which when multiplied, will give you the sum? It's quite clear that this one will always be smaller than that. When you're multiplying, you get bigger numbers. All right. So, but then now they're equal. What can they be equal? And if so, how often? Okay, now the way to do this is actually, it's not easy because you've got one equation with 3 unknowns. And how do you solve that? You need to have 3 equations if you've got 3 unknowns. But there is a nice, neat way of doing it. And that is, what I'm going to do is these 3 numbers, I'm going to say that the smallest is A, and the second smallest is B, and yeah, so let's assume that these are in ascending order of magnitude, of size. All right. So what does this mean? It means now that all of them are less than C. So you get A, B, C is less than or equal to, A is smaller than C, B is smaller than C, and C is equal to C. I'll put less than here. So I got 3C. So ABC is less than 3C. I can cancel because you can only cancel an inequality if it's positive. But this is a positive integer, so I can cancel. So I have that AB is less than or equal to 3. Now that really brings it down because these are positive integers which are less than or equal to 3. So what are the possibilities? You have that AB is equal to 1, or AB is equal to 2, or AB is equal to 3. Now you've got 2 integers whose product is equal to 1, both positive. It means that A equals B equals 1, right? So now when you got A equals B equals 1, and then, yeah, so if A equals B equals 1, let's see if this gives you a solution. So on this side here, you got C, A equals 1, B equals 1, and C, and here A plus B will be 2, 2 plus C. Now this is impossible. C can't be equal to 2 plus C. So this is impossible, which means it means that AB is not equal to 1. Because if AB equals 1, you get an impossible situation. C can't be equal to 2 plus itself. Otherwise, 2 is 0. And you cancel the C's. So if this is true, then you have an impossible situation. Let's try A equals 1 and B equals 2. Now here you will have, I'm going to put this in pairs here. I could have 1, 2, or 2, 1. I could have it like that. And then in that case, AB is equal to 2. So if you substitute it inside here, AB is equal to 2. So you have 2C is equal to, now, A plus B in both cases is 3. whether it's 1, 2, or 2, 1. So I got 3 plus C, right? And that gives you 2C is equal to 3 plus C. Bring the C's to one side, you get C equals 3. So here you get a value. You get C is equal to 3. All right? And the question is to determine A plus B plus C. So in this case, you got A plus B plus C. A plus B is in both cases, it's 3. And 3 plus 3 is 6. So in this case, actually, you can eliminate this one here because we said A is smaller than B, right? So that can be taken out. Because we started off by saying that A is smaller than B. So you got A equals 1, B equals 2, and C equals 3. And in the last case, AB is equal to 3, then this means that A is equal to AB. You got two positive numbers, integers. The only way you can have this is A plus B, AB is equal to 3, or 3, 1. And again, A is smaller than B, so we can eliminate that. And in this case here, you got AB is equal to 3. And let's see what happens here. If AB is equal to 3, then you have 3, that's AB. And in here we are saying 1 plus 3 is A plus B is 4. A plus B is 1 plus 3 plus C. And that gives you C is equal to 3 minus 4, that's negative 1. And that's false because it's given that they are all positive integers. All right? So this does not lead to a solution, which means that AB is not equal to 3, is not equal to 1. So there's only one answer. So one answer only one solution. Namely that ABC equals 1, 2, 3. And you can see, mentally, you can see that when you add these, you get 6. And when you multiply it, you still get 6. So, but that's the only solution. I want you to study this carefully because this is all very logical. You see, there's a lot of arguments which are going on in the head here. It's just not calculations. Maths is not all about calculations. It's about arguing logically to come to conclusions. So here, every time you have something, the equations are supposed to be speaking to you, like the way they speak to me. See, so I know AB equals 2. I say, okay, they are positive integers. What are the possibilities? And then I write it down. See? So you take the given information and you use it to solve your problem. All right. This is a nice problem involving integers. And there are lots of problems which involve integers, like this one. And you always, there are certain ways to deal with the integer problems. But just bear in mind that the numbers are all whole numbers. And that makes a very big difference. Helps you to get to the solution very quickly. Okay, so let's just get on to question 4 now. Question 4 says, you got two squares, A, B, C, D. So you got a square here. And you also got, this is also a small square here. Okay. And so you got one small square sitting inside a large square. Okay. They said the length of CG. So when you join this part here to that length is CG. That is equal to 9. So let me just write that down. CG is equal to 9. And the area of the shaded region is 47. So we can just put on this 47 here. I'm going to put it there in the shaded region. So this represents the area. All right. Now, so they don't tell you what the sides are. Okay, so let's assume the sides of the big square is A and the small square is B. The question is calculate the perimeter. They don't tell you what the sides are, but they give you two pieces of information. One is the length of a line and the other is an area of some region, and you don't know what the sides are. Okay, So let's make the sides, you can say let the sides be A for the large square and B for the small square. Normally I'll write all this down, but I'm putting it in the pictures so that we can save some time. I should say let the side of the large square be A and the small square be B. Now, by choosing it like that, then this becomes hypotenuse, you see. So what you have is that A squared plus B squared. These are two sides of this right angle triangle. It now is CG squared. It's hypotenuse. It now becomes 81. So now you've got an equation, a single equation involving A squared and B squared. Now, also, this area here, the shaded area, can we get an equation there? Well, the shaded area is actually equal to the large area, the full square minus the small square. You can see by the picture. The shaded area is the full square minus the small square. And the full square, the area is A squared, the area of a side of a square. The area of a square is equal to the square of the side. That's A squared, and the small square is B squared. And we are told that the shaded area is 47. So if you combine these two things, A squared plus B squared, A squared minus B squared, now you've got two equations and two unknowns. And you can calculate what these things are. And look, I can add quickly and I'll get 2A squared. The B squared will cancel up. If I subtract, I'll eliminate the A squared. But I just want to work out the A squared, 2A squared, yeah? And when you add this, you get 128. And I see A squared is actually equal to 64. Right? And that gives you a nice answer. A is a positive number. It's either 8 or minus 8, but it's a side of a square, so obviously it can't be negative. So you take only one square root, so A is equal to 8. Okay, now what is a perimeter? Now, the perimeter means you're taking, let's go right round the area of this shaded region. I must add that, and add that, and add that, add that. Then I add this, right? But this is the same as adding that, right? Because this is the same as that. Okay? So I'm putting the tick not here, but I'm putting it there. And I must add this, and it's the same as adding this part here. So when you when you work out the perimeter, you got all these ticks, and you will see all these ticks is actually the perimeter of the large square. You're going all the stick here, that right round, you'll see ticks along the boundary. So this is actually equal to, the perimeter is equal to the boundary of the large square, which is 4 times 8. 4A, because the side of the square is A, 4A, and we've already worked out A. So the answer is A is 8, so it's 32. Okay, so it's a nice problem where you're not given the size of the square, but you were able to calculate its perimeter. Okay. Just by using the information, creating equations, it's the same kind of thing. In problem solving or in any mathematical problem, the idea is to create equations using the information and solve the equations. You spend a lot of time in the high school solving equations, right? And very often you ask yourself, why am I doing all these stupid things just to keep solving equations, right? There are lots of jokes around it, find X and so on. So, but you can use those equations in problem situations like this to actually solve them, but you have to create the equations, right? That's where problem solving comes in. And that's what makes mathematics interesting, because you have to create the equations and then solve it. Unlike in school, where you are given the equations and you're asked to solve, which is really a rather silly thing. You want to know why do you make all these equations? The people have got every right to say that this is, there's neither rhyme nor reason in a lot of mathematics that you do in school. But this problem solving, Olympiads have very good applications. All right, now you got how many natural number pairs? Again, natural number. This is nice. As I said, it's the numbers are 1, 2, 3, 4, and so on. Those are the natural numbers. But you also are told that A is greater than 1 and B is greater than 1. So the values from A are from 2 onwards. 2, 3, 4, 5. And B is also 2, 3, 4, 5 because they are natural numbers which are bigger than 1. And again, you got a similar thing what we had earlier on, but this time you got 3 square roots. But you can still do the same thing and square on both sides. I'm not going to spend too much of time on this because we have already spent some time on this. So you got A, when you square the first one, you get A minus 1. As we saw earlier on, the middle term is 2 times the product of these two. And then the last term, when you square it, you get B minus 1. The square root disappears. And on this side, you have AB minus 1. You have to square on both sides. So when you square this, you get AB minus 1. Okay, so now you can bring all the square roots to one side. So you have square root of 2A minus 1, right? And you bring all the other numbers to the other side. Okay, I'll do it. AB minus 1 minus A plus 1. That takes care of that. And here you got minus B plus 1. I'm bringing this to the side. Change signs. And then here minus 1 plus 1. So here you have AB minus B, or minus A minus B plus 1. AB minus A minus B plus 1. Now this thing looks as if it's factorizes. So you got A into B minus 1. And here, minus B, I can get a B minus 1 here by putting a minus 1 in front and make it B minus 1. I can take out the negative 1 and I'll have B minus 1. Now that's very nice because I've got a common factor here. So this is A minus 1. So B minus 1 comes out as a common factor, and the remaining factor is A minus 1. Oh, well, now you got exactly the same thing on this side. So let me give a name to this. Let's call this X. Let's call this Y. So what have I got? I've got 2xy and if this is x, this is x squared. A minus 1 is the square of that. Is x squared, y squared. Okay, it's easier to work with small symbols rather than these clumsy ones. I can see A minus 1, B minus 1 occurs twice. I'm going to give it a new name. You see, this is what I did earlier on. Right? When I had A plus B plus C, it's occurring a couple of times, I give it a new name, and then it simplifies the calculation. So here now, I can take out, bring all to one side, and I have xy into
Prof,
xy.
Prof, sorry to disturb you.
Yes.
Uh, I think we have done this session before. You were supposed to do session 9, not 4.
Rather late in the day.
Yeah.
I asked this question, and somebody told me session 4 at the office. I've done all this before. I can't even remember what I do. Oh, okay. All right. Look, I have done this thing before. I'm sorry. Oh, somebody pointed this thing out in the chat group.
Yeah.
Okay.
Yeah.
All right. Sorry about this. Let's go to session 9 then. Oh God. I must go to session 9. You see, I forgot what I did and what I didn't go over this. So I'm not prepared for this. All right. let's do this, try to see what we can do. We already lost 43 minutes. That's quite unfortunate. We'll see how much we can do. A sporting club has 100 members. Of these 100 members, 44 play soccer, 45 play cricket. So this is a problem involving Venn diagrams. Okay, evidently. So let's put the club. Club has got 100 members. We'll put the club in rectangles. Normally, the full set, we put it with inside a rectangle. All right. And then let's look at those people who play soccer. There are 44 people who play soccer. Sorry, I didn't send this session 9 to everyone. Kotso, I also sent you session 4. All right.
Yes, you send it to me.
Yeah. Sent you the wrong one. Okay, 44 plays soccer. So let's just have a circle here to say these are the soccer players. Call it S for soccer. And 45 play cricket. And some of them will play soccer and cricket. So often this happens. So the 45, these are not carpets now. And these are soccer players and cricket players. You use a diagram sometimes to illustrate certain concepts. And 50 play rugby. So we'll call this R. Okay, now I've used, and there are 100 people altogether here. So entire set, this is the whole soccer club, and amongst them you got these people. 44 play soccer. So all these are all 44, the total amount. And 45, so I'll just put 44 here. That's equals 44. And cricket is 45. And rugby is 50. Now 8 plays soccer and cricket only. So there's soccer and cricket. So So 8 people play soccer and cricket only. Now, and again, they tell you rugby and cricket only, soccer and cricket only. They don't tell you how many play all 3. So let's just call that X. That will help me a bit. Because 8 play soccer and cricket only, so it means that if this is X, then this has to be 8 minus X. Because these two together give you 8. Now, likewise, 8 play soccer, 9 play rugby and cricket only. There's rugby and cricket, and the rugby and the cricket are in between here. These are the people who play. They are in the cricket side, they're also in the rugby side, and these people only played these. So there are 9 of them altogether. So this part becomes 9 minus X. Okay. And 7 play soccer and rugby only. So you got 7 play these two. So this becomes 7 minus X. Okay, so now 5 play none of soccer, cricket, or rugby. That means the 5 were outside. These are the bystanders. They don't play any of these games. Okay, and so now we know outside is 5, and you got various X's here, and the total is 100. So you can add all these numbers, and you can solve for X. I'm not going to do it because we're running out of time. So when you add this plus this plus this plus this, right? Oh, yeah. Now, I should have said, here you got these 3 together gives you 15 minus X. 8 minus X plus X is 8. 15 minus X. And you got 40 altogether. So here you have 25 plus X. When you add up all these, you're going to get 40. And here So again, here too, when you add up all these, you got 8 here, plus 9 minus x is 17 minus x, and you got 45. So this is 28 minus x, like that. And then here also, you got 16 minus x, so you have 34 minus x. So if you add up all these numbers, you're going to get 100, right? Solve for x. I don't know what x is. But then they asked you, how many people play rugby only? So the number of people, solve for x, the number of people who play rugby only, as you can see, is 34 minus x. Once you solve for x, then you can, these are the people who play rugby only. They don't play any other sport. So that is how you solve this problem. Okay? So the trick here is to start with the center one. Even the previous one, we did the same thing, where we had 3 carpets. So that's a nice place to start. And that from there, you will build up the entire information using the. All right, so let's see now. Question 2. Okay, it says that the number 16 is placed in the top left-hand corner of a 4x4 square. All right, let me redraw the square here. Okay, 4x4. If I had known, I would have drawn this thing beforehand, so I wouldn't have to waste any time redrawing it. Okay, so the number 16, some of these are shaded. Let me just shade those parts. So this is shaded here, this is shaded here, this is shaded here, and here, here, here. Right. So the number 16 is placed here, top left corner. So 16 is here. The remaining 15 squares are to be filled using all the numbers from 1 to 15. Once only. So the rest of the numbers are 15. So this is a magic square. So that the sum of the 4 numbers in each row, when you add up all those rows and you add all the columns, I'm sure you've seen magic squares before. And even the diagonals, they're all exactly the same, right? And the question is, what is the sum of the numbers in the shaded squares? So it looks like quite a difficult problem because you don't know what numbers go in here, right? There are any numbers from 1 to 15, which goes in here, and so you don't know what these are. So this is the power of mathematics. All right, so what I do know is that when I add up all the numbers, right up to 16, so these are all, okay, some of the sides, the common feature is x, common number. Right? When you add those 4, 4, 4, so you get 4x. Because this also gives you the 4 rows. You add up all that, you get 16, and that also is the sum of all 16 numbers. Now you know how to work this thing out. So 4x, by now you should know that the sum of consecutive numbers from 1 to n is n into n plus 1 over 2. So these are all consecutive. So it's n 16 times 17 over 2. 2 goes to 8 times, and x is 8 times 17 over 4. That's 2 times 17, which is 34. So they all add up to 34. So the common number that they all add up to is 34. Now, that means now I can actually add all the white squares. I'll tell you why. sum of white squares or unshaded. Right. Okay, I'm going to tick them off. Let's take the diagonals. And I'm going to tick it off. Those 4 add up to 34. Right. Then I'm going to add these 3. Now the whole 4 add up to 34. So these 3 will add up to 18. Because the 16 is already here. Then I add these 3. The same reason, these 4 will add up to 34. So those 3 will add up to 18 again. So this makes 70. 18, 36 plus 34 is 70. So the sum of the unshaded squares is 4. But then that tells you what the shaded is. Because when you add the shaded and the unshaded, you're going to get 136. So 4 times 34. So it's 4x, which is 4 times 34, 136 minus 70, because that's the unshaded. And that gives you 66. All right, so it's a very nice problem. Without knowing what these numbers are, but you know what their sum is. Okay, that takes care of the second problem. Sorry, I have to go a bit fast because we made a big blunder. Nobody informed me that I was doing the wrong thing. Question 3. So you've got this rather small looking diagram here. I wish I knew how to make this big. Oh, there is a select function here, but it's not working. Okay, so you got this diagram. I'm going to redraw this. 3 squares are aligned along the x-axis, and I'm going to try to draw it. So that's a nice big diagram. You get a small square here. You get a slightly larger square here. Oops. And then you got an even larger square here. Sorry, it's all not very nice. Okay, but they give you coordinates of some of these things. So here, the coordinate is given as 0, 4, and here it's 21, 12. So they give you the coordinates only 2 points. And they ask you to calculate the shortest distance between the points A and B. The A is here, and B is there. The shortest distance between these 2 points will be the straight line. So we need to calculate the length of the straight line from A to B, which I'm going to draw in red. All right, so we need to calculate AB. So that's a problem. So how do you do that? Well, this is a hypotenuse of a right angle triangle. So I need to know this length and also this length. I need to know those 2 lengths. Now, to do that, you have to understand what do you mean by coordinates of a point. Okay, so this is a good exercise in coordinates. So whenever you have a point, what do you mean by its coordinates are something? When you put a point here and you say its coordinates are x and y, then what it really means is that x is the length. You come right down. I normally go right down to the x-axis, and then I measure that distance to the origin. Some people do this, which I don't like. Right? Please try to always do this, and you'll when you this will help you a great deal when you're doing calculus and graphs to understand that x is the distance along the x-axis, and the y is from the y you can do it from here to here. That's not a problem. But x we normally do it from here. Okay, so that is what y is, this length here. So we need to work out that this length is easy because it's the same as this, and that is 12. It's the y coordinate of this point, which I just told you is 12. So this is 12 here. Okay, so the only thing I have to do is to calculate this length here. Now, how do I calculate that length? It's all along the x-axis. Now, you've got 0, 4, which means that the distance, the 4 is the distance from here to here, but this is a square, so this is also 4. All the sides of the square are 4. So I need to know, work out all these horizontal distances. Now here, this is 12, so this is also 12 here because this is a square here, right? But you know the x-coordinate of this point is 21. So this entire length here, you see, the x-coordinate from this point to this point, this is it. This is 21. I already got 4 and I got 12, that makes 16. So this part here will be 5. Okay, so now you have this thing that we wanted. This is 5. So AB can now be quickly calculated because that's the square root of, you've got two sides, 5 and 12. It's 5 squared plus 12 squared. And this is a very well-known Pythagorean triple. It's 13. 5, 12, 13 are the sides of a right angle triangle. Okay, so that gives you the solution to problem number 3. Okay, so let's just go on to problem number 4. So this last problem was all about coordinates and interpreting coordinates in a proper way so you know what the lines are. So question 4 is this: points A and B with the respective coordinates 3A and 11B. Okay, we need to draw a diagram here. So 3A, that means the x coordinate is 3. So let's just go here. The other one is 11. So I can go, say this is 3A. So this part is 3. And that part is A. Just remember that. And then 11. 11 here, 11B. So let's just make it here, for instance. So this is 11B, right? So you don't know what small a and small b. They lie on the same line, but you know the equation of that line. Equation of the line has got a square root in it. So the equation of the straight line is y equals root 35 x plus k. Okay? Now, so this looks like a problem in coordinate geometry, but even if you haven't done coordinate geometry, I think you can still do this problem, because now you want to know what the value of k is. Well, actually, you want to know what the distance between A and B is. So we need to calculate this distance. This is capital A, this is capital B. Okay, so how do you calculate that? Well, The usual way is you must try to create a right angle triangle, because that's the only way you can calculate distances in algebra, or mostly. So let's draw a right angle triangle here. Make that the hypotenuse. See? So now you must remember this 3 is, as I told you, this is from here to here, and 11 is from here to here. So this is 11. So that means this part here is 8. You see, the coordinates can be used to calculate distances. So if this is 8, then this is also 8, because you've got a little rectangle here when you're completing this thing. So we are almost there, because we've got one side of the right angle triangle. Now the other side, again, using coordinates, this whole thing is B. It's a y coordinate of that. And here, the y coordinate is A. So we can put an A here. This is a rectangle. So the whole thing is B. This part is A. So this is B minus A. So your AB is actually equal to, we can work out AB squared, is 8 squared plus B minus A all squared. All right, so you see, you might have to look at the question and then try to solve the question. And that is what I've done here. I've built up all this information here from the question. And now the only problem is, what is B minus A? All right, now we know that these points are on that line, you see, it's very, very important. It means that the x coordinate and the y coordinate satisfy this equation. I can put y equal to A. The y value here is A, is equal to root 35, and the x is 3. So this is times 3, right? Plus k. So you can substitute the y value into x and y value into the equation, because this point lies on the line. Whenever a point lies on a line or a curve or anything like that, the x and the y coordinates satisfy the equation of that thing. That is why they tell you y equals 2x squared minus 1 or whatever it is. When you've got a point on the curve, then you can put these x coordinate, y coordinate on that. Likewise, the same way here, you got b is equal to root 35 times 11 plus k. Now the problem is to find b minus a. Okay, so you just have to subtract. Now this is root 35 times 11 minus root 35 times 3. So I can take out root 35 as a common factor. You get 11 minus 3. K minus k rapidly disappears, so you don't have to worry about that guy. So this is 8, the root 35. So this is 8 times root 35. So b minus a all squared is, this is b minus a. So this is 8 squared plus 8 to 35 squared. So that's 8 squared times 35. So I don't even have to calculate this, because when you square this, I get 8 squared times 35. Now I can take out 8 squared as a common factor. So you don't need calculators. 8 squared goes into this 1 plus 35. That's the power of mathematics. See, the algebra. So this is a common factor. 8 squared goes into this. So this is 8 squared times 36, which is very nice, because that is 6 squared, right? 36. So you get AB squared is 8 squared times 6 squared. So AB is a lovely answer. 8 times 6 is 48. Okay, it's a nice problem involving graphs and understanding what you mean by coordinates. All right, so we get on to the next problem. So all this will help you in your exams, because this is largely high school mathematics that we are doing here, which is quite nice. So you got another thing. Y equals mx plus b be the image when the line x plus 3y is reflected in the x-axis. Okay. Let me skip this because I'm sure that'll take a little bit of time to do. And let's see what the others are. If I've got time, I'll come back to that. It's reflection, so it requires a little bit more depth into understanding graphs. Let's go to question 6. Question 6 says, let star x be the sum of the digits of the positive whole number x. Okay, now star, so this is like a function. The star is a number, star is a rule. This is a rule. When you put brackets around it, it's a rule which takes x into its sum of the digits. So the star, it takes 8 into the sum of the digits. There's only one digit, so it's 8. But here, star of 123, it takes 123 into the sum of the digits, which is 6. Now you have to remember what star is. Star is, it takes a number into the sum of the digits of that number, right? You have to digest that properly. Because in this question here, you got double star. You got star of star x. Equals 3. So you have to solve for x, right? But you got a double star here. So how do you how do you find x? So let's just, excuse me. Let's understand what this is. It means that the sum, now inside this outside bracket is this. So the sum of the digits of the inside one is star of x. Be careful here now. The outside is star of the sum of the digits of inside, which is this is the inside here. 1, 2, 3, 123. Sum of the digits of this is 3. Right? So which number has got the property that the sum of the digits is 3? So now you look at star of x, right? The sum of its digits is 3, so it could be 3. The sum of the digits of 3 is 3, or it could be 12, because the sum is 1, 2, or you could have 2, 1. We could have had 3, 0. They ask you how many different 2-digit numbers. Anyway, I'm writing down all the numbers. So you've got 3, 0. The sum of the digits is that. So I think, yeah, you're not going to put 1, 1, 1 now, for instance. So it's too big, because that also has sum of the digits is 3. Okay, if star of x is equal to 3, let's see what that means. It means that the read this thing again. It means the sum of the digits of x. Now the inside is x. Sum of digits of x is 3 or 12 or 21 or 30. There are 4 possibilities. And x is a 2-digit number. Right? X is a 2-digit number. It's only got 2 digits in it. Right. Let's take 3. Which 2-digit numbers have got the sum equal to 3? It's 3, 0. Or you could have 12. Or you could have had 21. I think those are the only 2-digit numbers whose sum is 3. Let's try 12. Which 2-digit numbers have got the sum of the digits is 12? Well, you could have had, you can't start with 1. because you want digits, right? So you can start with 39. 39. Oh, I could have had 48. Oh, yeah, you can't have two. You can't have two. So 39, 48, 57, 66. And then you have 75, 84, 93. These are digits which have got the sum equal to 12. So I've finished with that. And then the sum of the digits is 21, but you can't have, because the largest two-digit sum is 18, 99. That gives you the largest two-digit sum. So you can't get 21 and you can't get 30. So these are the only ones which have the sum of the digits equal to 3 or 12. The question is, how many different two-digit numbers do you have? And you just have to count all these things here. It looks like the answer is 10. I haven't checked this thing out, so it may be wrong. But I got 3 here, 6, 10. Maybe there's something else as well. Okay, so here the whole thing is understanding what do you mean by this rule. Normally they use the symbol f of x to give a name of a rule. This is a rule whose name is f. It takes x into something, right? And that's the rule. Like if I had f of x is equal to 2x, I mean the rule takes x into twice itself. So it takes 5 into 10, 20 into 40, and so on. So normally when you put y, it's something else. It's the same thing, but there it's for graphs. But yeah, when you're doing functions, you do it like that. Okay, let's just get on. Sometimes I get carried away with unnecessary things. So let's go to question 6. Okay, so no, question 6. I'm supposed to be doing question 6. Oh, okay, I finished question 6. I'm now at question 7. All right. Now there you see you've got a rule here, f of x. So this is what I was saying before. Now this rule, it takes x into all these funny looking things here. And a, b, and c are constants. They are not told what they are, but they don't change. They are constant. But the x can change. You can put various numbers for x, right? And you get different things. Like in this case here, the x is given as -7. So f of -7, right? It's equal to -29. But let me put x as -7 here. So the a doesn't change. X is -7, so I must put that in brackets because I'm raising -7 to the 7th power. And b, I have to put that in brackets because you got a negative sign. So here it's -7 cubed. Put that in brackets also. Plus c times -7 plus 5. All right. So 5 doesn't change. And this is equal to -29. Because they tell you that f of -7 is -29. Oh, they just give you that and they ask you to find what is f of 7. Okay. Now let's just simplify this. Okay, let's do f of 7. F of 7 is a times 7 cubed, 7 to the 7, plus b times 7 cubed. I'm putting plus 7 here into that equation, plus c times 7 plus 5. So we need to work out what this is. All right? Now, let me try to simplify this thing here. This is a times -7 to the power of 7 is a times 7 to the 7. But there's a minus sign in front because the -1 is raised to the power of 7. That's an odd number. So -1 raised to any odd integer is -1. -1 cubed minus 1. So this is again an odd number. So it's minus b times 7 cubed. And this is minus 7c times 7 plus 5 is equal to negative 29. Now I need to calculate this thing here. Plus 5. Okay, I already got the 5 here. Now that can be calculated nicely, because if I take these three things to the other side, I'll have 5. This is minus 29. So I have 5. Bring this to this side, it becomes plus 29. I'm doing that because I just want to calculate this part here. Now, what is this? This is, when I take it to the other side, I have a times 7 to the 7 plus b times 7 cubed plus c times 7. So this is 34. Now that's beautiful, because now we know that this part here is 34. Therefore, f of 7 is 39. So this is not very hard, but you have to ask yourself, what is the question? What is given? See, I wrote down the given information, and I found out what is the question, f of 7. So I need to calculate this, right? I know this 5, but I don't know this part here. But this part can be obtained from there, right? With a little bit of thought, you will see all these things are all negative, because you got odd powers, you see? Minus 7 to the 1. So they're all negative. So that helps a great deal. Okay, so let's just get on to the next question, which is now question 8. Okay, given that f of 3 is equal to 3, and you got some formula here, and you're supposed to calculate the value of f 2022. So f of 3, so you know what f of 3 is. So I can substitute x equals 3 here, then I got f of 3 here, you see. So that is nice. I can work out f of 6. So it's f of 3 plus 3. Then n is equal to 3 now. So you can put the 3 inside here, and you get 3 plus 3 is 6. So this is f of 6 equals, now this is a fraction. This is f of 3 minus 1. Let me do it like this, f of 3 minus 1 over f of 3 plus 1. Because that's what the formula says. But f of 3 is 3, so it's 3 minus 1 into 3 plus 1. And 3 minus 1 is 2, and 3 plus 1 is 4. So f of 6 is half, okay, which is very nice. So now I know f of 3, and I know f of 6. So I can calculate f of 9 now, because this is 3 plus 6, you see, 6 plus 3. So I can put 6 into this equation. So you got f of 6, f of 9. I could put n equals 6, then I'll have 9 here, f of 9, which I've got here. The f of 6 minus 1 over f of 6 plus 1. And we already calculate this to be half. So it's half minus 1 over half plus 1. And then this is minus half over 3 over 2, 1 plus half. And that gives you minus 1/3. Okay, so you can calculate f of 9. Let's try again. We're not getting anywhere. It will take us a long time to get to f of 2022. But there must be some kind of a pattern here. So let's try f of 12 now. And this will be f of 9 minus 1 over f of 9 plus 1, as we did before. F of 9 is minus 1/3 minus 1 over minus 1/3 plus 1. Right. Now, let's multiply numerator and denominator by 3. I don't like fractions, so I'll multiply top right throughout by 3. I get -1 minus 3. And when you multiply this by 3, I get -1 minus 1 plus 3. And that gives you -4 over 2, which is -2. So we're still not getting anywhere here. And so we got f of 3, 6, 9, 12. Let's try f of 15 now. The next one is f of 15. All right. Now I can do it straight away. F of 12 is -2, -1. And here I've got, because the last one is -2. -2 plus 1. -3 over -1. Oh, I've got 3. Okay. So I'll come back to the starting point. So it means that f of 15 is 3. So f of 18 will be this, the next one, because it's the same calculation. The f of 21, f of 24. So this tells me that the various numbers 3, 6, 9, and so on let me create some space here. Oh, maybe I need all these. Right, so my sequence, if I may use that word, it starts from f of 3, 6, 9, 12, 15, going all the way up to 2022. Now, it looks, these are all multiples of 3, and this is also a multiple of 3, right? Because it's 3 times 674. 3 times 674. Okay, so this is 3, and this is a half, and this is -1/3, this is -2, and this is 3. All right, so the 3 and the 15 land up with 3. So 3, let's see what happened. The sequence, now then it becomes the same thing. 3, half, -1/3, -2, 3. It just keeps going on the same way. It just keeps repeating. So let me just see which ones go to 3. And so I have 3 and 15. They both go to 3. This is, so the next one will be 27. That goes to 3 as well. And then I got 39. That goes to 3. So we want to know now, what does 2022 go into? Okay, so let's see what this. Now this is an arithmetic sequence here. The nth term, 315, is a into the common difference is 12 into n minus 1. So 3 into 12 into n minus 1 goes into 3. Right? Because you can see this is the general term. Now, I don't know whether this 2022 is one of these. Okay. So let's divide this by 12. I think you have to divide this by 12 and see what happens. 2022 divided by 12 is 2016 plus 6. Doesn't go exactly. So this is 2022 is 6 plus 12 to 168. All right. So you got 3 plus 12 times 168, according to this, goes to 3, right? So 6 plus that will go into a half. So we've got 2019, that is 3 plus 12 into 168, right? That goes into 3. So the next one, 2022, right, will have to go into a half. The sequence is 3 half. So the answer is a half. Okay, so that's quite a hard problem. It involves even arithmetic progressions and functions and sequences. So it's a rather complicated problem, but I hope you were able to follow that one. Okay, so we don't have much time left. Okay, you've got some other question which is similar. Let me not do that. It's a little bit tricky. Okay, there are a few other problems here, but let me do something. See, here too, they ask you what is the value of something. You just have to substitute some numbers and see whether you can make some sense out of this. See, like one of the numbers I would like to substitute is n equals 2024 because that gives you a 0 here. See, and that helps a great deal to work out something. And then you'll try some other things. So you've got a formula for all values of n here. All right, so we won't go into that one. This one, f of n is n squared plus 3n plus 2. Okay, so now here you've got terms like 1 minus 2 over f of 1, 1 minus 2 over f of 2, and so on. So why don't we have a general formula for 1 minus 2 over f of n? Then I can substitute in all these, and I will be able to work what these fractions out. So this is 1 minus 2 over f of n is n squared plus 3n plus 2, right? I need to work out f of n because you see those things appear in the denominator here. And I can simplify this. This is 1 minus 2 over, let's simplify it straight away. The common denominator is n squared plus 3n plus 2. N squared plus 3n plus 2. When you multiply it by 1, you get n squared plus 3n plus 2 here. And then you get minus 2. Right? When you simplify this. So difference of two fractions, common denominator. The 2's cancel. And you have n squared plus 3n. You can factorize it. N squared plus 3n is n into n plus 3. And this one here also factorizes. It's n plus 1 times n plus 2. See? And this Yeah, I was hoping that it'll simplify. Easier way, but anyway, it doesn't do that. It's a little bit more complicated. So this is it. So we're 1 minus, the first one is 1 minus 2 over f of 1. You can put n equals 1 here. You get 1 times 4. 1 times 4. 1 plus 1 is 2 times 3. N equals 1. So that's the first one. The second one is 1 minus 2 over f of 2. Right? Now, n equals 2, and that is 2 times 5. N equals 2, you have 3 times. No, I'm sorry, it's 2 times 4. Oh, yeah, 3 times 4, like that. So when you go all the way up to 2025, you get 1 over, or you can put 2025 here. All right, so it means now this thing here, you have to simplify this thing. They're all being multiplied. They're all being multiplied. They're not being added. These are all products. So I can multiply all these numbers together, which I just calculated. I get 1 times 4. The numerator, 2 times 5. And I presume 3 times 6. 4 times 7. And so on. And going up to n equals 2024. So it's 2024 times 2027. Going up to there somewhere. All right. I think it may be a little bit different, but anyway. Right. And then in the denominator, you've got 2 times 3 times 3 times 4. And then, of course, the next one will be 4 times 5. And so on, going up to 2025 times 2027 and 2026. Now, you see a lot of things will cancel here, right? I'm going to leave that to you. You can see a lot of things will cancel, and this thing here will simplify to a very nice fraction. Okay, I forget what the answer was, but it was some nice fraction. You can bring in factorials here. You see, it's 1 times 2 times 3, and so on. And then here you got 4 times 5 times 6. So you got factorials notation. If you just take the alternates, and that will simplify considerably. Okay, so try that one, and it'll involve a little bit of work, but you can get to that. And then I'm just going to do one more. Maybe I better do this. Nice geometry problem. Right, the diagram shows a cuboid. A cuboid is not a cube, it's a rectangular cube. The sides are not the same. In a cube, all the sides are the same. So you can see the sides are given as A, B, and C. Right? Now, given that AB is equal to 6, and the sum of all the edges is 28, find the total surface area of the block. Okay, now this looks like a tricky problem. So let's see, what is the total surface area? Let's focus on what the problem is. Right, then you know we direct our attention towards that. So there are 6 faces here. So you have to work out the 6 areas. That's the surface. Right? The one that is facing us is AB, but there's one behind it also, so that's 2AB. And there's one on the side here, right? And that is B, this is C here, same as that, and this is A here, same as the vertical. So that's 2AC. Because this together with one at the opposite it, and then there are 6 faces, so you got 2 plus 2 plus 2. The top face is the same as the bottom face. The bottom face is BC, so it's 2BC. So you need to calculate this quantity here. The only thing they give you is, they say AB is 6. Now, can we calculate AB? I don't know whether you have done this thing before, but when you have a diagonal of a cube, it's the trick is to actually join this part here to where this thing ends, and you will have like that. Now, what the trick here is that this thing here is a right angle triangle. See? Because this bottom line and the top one, this is on the floor, and that one there is on the wall. So this is perpendicular to this. It's a right angle triangle. And the sides are, this side is A, so that's fine. It's the same as that one. But this thing here, you got, this is a cuboid, you see. So this is a right angle triangle on the floor here. And this part here is square root of B squared plus C squared. So this is the hypotenuse of a triangle on the floor. So now you have a vertical triangle with one side A and the other side this. So therefore, this AB squared, this hypotenuse squared, is A squared, that there, plus the square of this. And the square of this is B squared plus C squared. So you got a nice equation. And AB is given as 6, so that we know that this is 36. So you got this equation, A squared plus B squared plus C squared. You know, what else do you know? You know the sum of all the edges is 28. Now, there are 12 edges. There are 4 on each face. 4 at the top. Oh. Okay, so you have the sum of all the edges. Okay, so let's take the 4 at the top. That will be the edges here. Sorry. Let's work out the 8, the 12 edges. The 4 at the top, which is the same as the 4 at the bottom. The bottom edges, they're just the perimeter of this triangle here. There's 2B plus 2C, right? So those 4, and then that's added twice. Those 4 plus 4, and then vertically you got 4 A's. So that gives you the 12 edges. So this is 4 into A plus B plus C, right? And that is given as 28. So you got A plus B plus C is 7. So now you know that, and you don't know that. Now here's something which is useful. You know the sum of a binomial, but if you got a trinomial, you got 3. The formula for this is A squared plus B squared plus C squared, square everything, plus you work out all the possible products of 2. We have 2AB plus 2BC plus 2AC. So that is how you square a trinomial. You add the sum of the squares plus all this, and then eventually you get this. Now you see, this part here is sitting right here now. That's your unknown. And here I've got, this is 7 here. So, and I know this. So that's beautiful because this is 7 squared, which is 49. A squared plus B squared is 36. So that goes to the other side. So the answer is 13. That's the area. I don't know. You can check the calculations because I haven't practiced this thing before. So I don't know. All right. So that takes care of that. And then that's the last one I want to do because let me just tell you about your assignment. The assignment for today is this. Oh, so you got you got a sequence here, 3, 15, 24, 48. Now you have to look at the patterns here. Consists of those positive multiples of 3 that are 1 less than a perfect square. All right, you can see. If you add 1 to each one of them, you get a perfect square. 4, 16, 25, 49. Now, what is the remainder when the 225th term of the sequence is divided by 9? I just want to tell you something about the remainders here. It's very easy to work out the remainder when you divide by 9, right? If I want to work out the remainder when 2, 9, 3, 5, 4, 8, 7, and I divide by 9, what is the remainder? All you do is you add up all these things, right? 2 plus 9 plus 3 and so on. Right? 14, 19, 23, 31, 38. Right. And then divide that by 9 and work out the remainder. So when you divide this by 9, right, the remainder is 2. So you don't have to divide that number by 9. You have to just divide the sum of the digits by 9. And whatever the remainder is, it will be the same as the remainder as the original one. You see, like if the remainder is 0, then it's a multiple. And we know that. When you add all these things, if it's a multiple of 9, then the remainder is 0. But it extends to all remainders, not just remainder 0. So I think you will be needing that fact there for this. You'll need to calculate the 2025th number and add the digits and divide by 9. Okay, so I've given you a big clue for that. I had to do that because I don't think you knew this fact. All right, so thank you very much for attending. And I must apologize for this late start and the long revision, but we seem to have done most of it. Hopefully, you still learned a bit. Somehow we survived this one. Okay. All right, so let me just get to everyone. Okay, guys, thanks very much for remaining till the end. I kind of rushed through this, and Khotso would have recorded this entire thing. And hopefully, he'll give that recorded session to you quite soon. And then if there's anything that you didn't understand, you can go back to the recorded session and try to go over it. But there were some useful things that I told you to